This was homework question. Yes, Vardhaman.
Sir, I have a doubt.
Yes.
Hello.
Ah.
Hello, sir.
Yes, Vardhaman. Tell.
नहीं है.
So let's see the solution. How many of you have got the answer? So first, let us write the starting statement of solving a numerical. Let two stones meet after time t. Okay, we can assume this. After that, for stone dropped from a tower, the initial velocity will be 0. Clear these three lines? Everyone? Clear these three lines? Okay. After this, we will have, let the displacement of stone in time t from top of tower be s. And the acceleration due to gravity, we know that 9.8 meter per second square. Okay. So which equation we will use? Which equation we will use? From the second equation of motion, we will calculate the displacement s. Okay. So you have got the values. Tell me the value of s. So our value will be 7.9 t square. And let us take this as equation 1. Okay. After this, for the stone thrown upwards, initial velocity equals to 25 meter per second. Let the displacement of stone from ground in time t be s dash. Okay. You can take S dash or you can take S1. So the question from Harith House 7.9, when we will use the second equation of motion S equals to ut plus half gt square, okay, u is 0, so you will get the value of ut as 0. Then half value of g is 9.8 into t square, okay. So when, one sec, when you will have 9.8 divided by 2, yes, you will get 4.9, not 7.9, 4.9. The 7 was just above the 4, so it has typed like this. Now for the displacement of stone from ground in time t, s dash or s1, acceleration due to gravity minus 9.8 because it is against the gravity. Again we will use second equation of motion in terms of s1. Again we will use second equation of motion for the value s dash or s1. You can take 4.9 round figure as 5. This time what will be the value? S dash or S1? 25t ut plus half gt square because it is coming down. But the value of g is against the gravity, so ut minus half gt square. So S dash or S will be 25t minus 4.9 t square. And this will be our equation number 2. After this, what will be the next procedure? The combined displacement, that means S plus S dash of both stone meeting at point is equal to height of tower. That means 100 meter. Clear? Put the values of S and S dash. You will get the value of time. So tell me the value of time. Because it is given top of tower. Read the question, Harith. Stone is allowed to fall from top of tower 100 meter high. Okay. So the total displacement of S and S dash, addition of both will be 100 meter. Tell me the time. Okay, Harith has got the time. 4 seconds. Next approach. Next, what we have to find? In 4 seconds, stone falling covered the distance by equation 1. So S equals to ut plus half gt square. Put the value of t and get the value of stone. Now, Harith, just read the question carefully. एक पत्थर को ऊपर से फेंका गया, उसके लिए स्पीड की जरूरत नहीं थी. एक और पत्थर को नीचे से फेंका गया, उसको स्पीड की जरूरत थी क्योंकि वो अगेंस्ट द ग्रेविटी जा रहा है, तो 25 मीटर पर सेकंड से गया. सेम टाइम पे दोनों पत्थर रिलीज हुए. क्वेश्चन इज दोनों पत्थर आमने सामने कब होंगे? ओके, सो फ्रॉम वेयर वी हैव स्टार्टेड, लेट द टू स्टोन्स मीट आफ्टर टाइम टी. एक टाइम टी के बाद अपने को वो दोनों पत्थर आमने सामने दिखे. ओके, सो वी हैव गॉट द वैल्यू ऑफ टी दैट 4 सेकंड के बाद दोनों पत्थर आमने सामने होंगे. ओके, नाउ टेल मी द डिस्टेंस. कितने डिस्टेंस पे वो दोनों पत्थर आमने सामने होंगे? पुट द वैल्यू ऑफ टी इन इक्वेशन 1. After that, put the value of no, only in equation 1 we can get, because we know the total height. U will be 0. In equation 1, U is 0. And take 4.9 round figure as 5. We have got the value of t from equation 1 and 2. Adding the right side values of equation 1 and 2, we have got the value of t. Just see the right side of equation 1 and 2. Equation 1 is 5t square. Equation 2 is 25t minus 5t square. Add both to 100 meter. So after this, we have got the t as 4 seconds, and after getting the value of t, we will put this value in equation 1, and we will get the value of s as 80 meter. Okay, But question again is not clear. The answer is not got that calculate when and where two stones will meet. So the two stones will meet after 4 seconds at a height of 20 meter from the ground. We have got 80 meter, that is for the distance, but the meeting point will be 100 total height of tower minus 80, that will be 20 meter from the ground. Done? Can we move to the next? Now just see the deleted portion of gravitation, that density part is deleted or not, because thrust and pressure in liquids has been deleted. Just see that density part is deleted or not. We have to do the questions on that also. Density part is deleted or not. Harit Raghav, tell. Relative density deleted, not density. Thrust, pressure, Archimedes principle, buoyancy, elementary idea. So all this has been deleted. Okay, means density we can do na. Density we can do. Okay, so let's do the questions on density. The volume of a 500 gram seal packet is 350 centimeter cube. Will the packet float or sink in water if the density of water is 1 gram per centimeter cube? What will be the mass of water displaced by this packet? So how we will start? Density of 500 gram seal packet equals to mass of packet upon volume of packet. Mass of packet upon volume of packet. So just put the values. What are the values? 500 divided by 350. 500 divided by 350. So tell me the answer. So it's 1.428 gram per centimeter cube. Clear? Now the question, will the packet float or sink in water if the density of water is 1? So the density of substance more than 1 means more than water will sink, and the mass of water displaced will be, how much mass will be displaced? 350 gram. Clear? Write it down as it is. Now a similar question. The volume of 50 gram of substance is 20 centimeter cube. If density of water is 1 gram per centimeter cube, will the substance float or sink? I'm getting answers only from two, Raghav and Harith. Rest of you, tell me the answer. Yes, Bhavik, the substance with density 2.5 gram per centimeter cube will sink. Okay. Three answers. Rest. So let's see the answer. We will start the answer as, if the density of object is more than the density of liquid, then it sinks. Okay. On other hand, if the density of object is less, it will float. This is the basic concept of density, volume. So here the substance density is, how much density substance is having? Mass of substance upon volume of substance. That means 50 divided by 20, and it is coming 2.5 gram per centimeter cube. Okay. So again the closing statement for the answer. The density of substance is more than the density of water, hence the substance will sink in the water. Clear? So that's all for buoyancy part, means this chapter part.